So the mandate is for SciMed to bring together the focus project teams depending on the type of project being developed. Our initial focus within SciMed is in the region of hydrocephalus, which is a build-up of CSF within the brain. And pediatric hydrocephalus affects 1 in 500 live births, and it's the leading cause of brain surgery in children. It's also an increasing issue within the adult population with regard to a normal pressure hydrocephalus associated with dementia. The usual treatment, which was developed in the 1950s, is the implantation of a stent, which you can see here, which then drains from the stent implanted into the skull through behind the ear under the skin, usually into the peritoneal cavity. However, this is prone to moving of the stent. It doesn't adhere properly. It can be blocked, and it can just malform, resulting in numerous or multiple surgeries. As you can see from this person, they've got numerous stents implanted in through their skull. So this is a need that we've identified through our neurosurgeon. This is the development of a new intracranial infusion system, and what we're developing initially is the actual device that is inserted into the brain. So this requires a number of key features. One is a mechanism for securing the device on top of the skull, and then it needs to be strongly integrated on the dense bone at the top of the skull, non-integrated in the trabecular bone, which is like a porous-like structure. It's sort of got pores within it, and then it has to have a channel through which the fluid can flow. So this is an example of the trabecular bone. It has sort of pore-like structures. So we require expertise in material sciences to develop titanium, such as this titanium material, which closely imitates the trabecular bone. Surface technologies, does the material require micromachining to form grooves? Would that help with the osseointegration? And maybe other materials that, such as the different types of titanium. And then what will promote osseointegration, what will inhibit integration as well. These key features and basic science underlying this research can be then applied to the development of other technologies, such as the fully implantable bone conduction amplification device, and maybe innovative new implant technologies. So fundamental to SciMed and to RSM generally is the inclusion and involvement of industry from the early stages of research programs. So we offer access to products, world-class interdisciplinary researchers, as well as project development opportunities, and these are the number of ways that you can work with us. We have a number of projects that are already sub-licensed, and a number of collaborative research projects underway. Industry can also benefit from working with RSM, as we are a clinical facility. We have the associated research labs, and we identify unmet patient and clinical care needs. We have directed research capabilities. Like I say, we don't do research for the sake of doing research. There is a need that has been identified. And we have access, we can provide access to our knowledge translation global technology networks. RSM provides industry and researchers with the chance to work with a truly interdisciplinary team in a translational research environment. Ta-da. Thank you.